Hi there, this is Robotic CP, and today we'll be discussing the parts of a pneumatic system. First part we'll be discussing is called an air compressor. This little machine here, it pressurizes the air around it and directs this air into a pneumatic system. This air is essentially what powers the entire pneumatic system. Sometimes, because the air compressor can get a bit shaky, people use vibration dampers to stabilize it on the robot. Next part we'll be talking about is the air reservoir, or also known as the storage tank. This thing holds compressed air that's sent to it from the air compressor, and it's normally stored at 120 psi. The next part is another essential part known as the pressure gauge. This measures air pressure in the system, and you have one place near every air compressor and near one every regulator. This is because you need to know the pressure going from a high pressure system to a low pressure system, which we'll be discussing later. By the way, PSI is pressure per square inch, which is the unit for pressure that we use in FRC. There are other units for pressure. We'll discuss those later. This here is a pressure sensor. This detects pressure in the system, and it sends an electrical signal to the user to warn the user if the pressure exceeds a set limit. So this is used to avoid pressure overloads during a game. Next part that we're going to be discussing is the manual air release valve. As implied by the name, it allows all air in the system to be released manually in case of a pressure overload. It's always placed near air storage tanks so that it can release the air from both sides of the system, like the high pressure side and the low pressure side, and it can release it all together at one time, since the air storage tanks and the compressor are mainly where the air is stored. This here is a regulator. Although it doesn't always look like this, it is always used to control air pressure and airflow. This is kind of like a transaction zone from high pressure to low pressure ports. It has 4 ports, as you can see. One port is usually blocked, and the other 3 are used for one is for high pressure, the next is from high pressure to low pressure, as indicated by the arrows, and the last port is for the pressure gauge, so you can measure the amount of pressure traveling from the high pressure side to the low pressure side. This is a solenoid valve. This is one of the most essential parts of a pneumatic system. It's used to control airflow to and from a pneumatic piston. 2 common types of solenoid valves are single acting and double acting solenoid valves. Double acting solenoid valve being the more common of the 2. Double acting solenoid valves have 5 ports, including 2 exhaust ports, 2 actuator ports, and 1 intake port, as you can see on your bottom left. And a single acting solenoid valve has 3 ports, which includes 1 intake port, 1 exhaust port, and 1 actuator port. These are all connected to a spike or a serial solenoid breaker board, which gives the solenoid valves power, and it usually gives the rest of the pneumatic system any power necessary. As you can see on your bottom right, that's the less common single acting solenoid valve, and on your left is the double acting solenoid valve. The next part we'll be discussing is probably the second most important part of the pneumatic system, known as a pneumatic actuator. What it does is that it basically is the end result, and it moves what actually moves in a pneumatic system to make your robot go up or down. And this here is how it works. When high pressure air is put into one side of the pneumatic piston, it pushes the rod upwards, and likewise when high pressure is put into the other side of the piston, air is pushed into the pneumatic piston, so that it moves back. At the same time as it's moving back, the air that had already been put into the first side is being exhausted. These pneumatic actuators include pneumatic cylinders and pneumatic motors. On your right is a pneumatic cylinder, which is less commonly used, and on your left are the most commonly used pneumatic cylinders, which are double acting cylinders. And these always go with the solenoid valves, as we spoke about it before. And pneumatic cylinders move in linear motion. The common types of pneumatic cylinders include single acting, double acting, spring, and ram. And double acting is the most common, again, as I said before. The pressure that's involved, like the amount of pressure, you know how we talked about the low pressure and high pressure systems, and how normal working pressure is 120 psi. Usually these pneumatic cylinders don't require 120 psi to move, and it's kind of unsafe to pump in 120 psi of pressurized air into a pneumatic cylinder, as it can break. The pressure that's required varies upon the weight that the cylinder moves. For example, if your arm weighs 130 pounds and your pneumatic cylinder has a bore size of about 2 centimeters, it would vary from what if your pneumatic cylinder has a bore size of 0.5 centimeters, the amount of pressure that you need to pump into the pneumatic cylinders. We'll talk more about this later on another different video. Of course, you need tubing that is essential to connect all parts of the pneumatic system. Common sizes of tubings are 1/8 inch and 1/4 inch. Fittings. These fittings are used to connect the tubing to the system. These include brass fittings and push-to-connect fittings. Brass fittings are used for tighter fittings and to connect two mechanisms, and push-to-connect fittings are easier to use and only used for tube-to-tube and mechanism-to-tube connections. Different types of fittings are for different purposes. As you can see here, there are many varieties of fittings. These cover most of the types of push-to-connect fittings. Pneumatic remote control. Of course, since we're in FRC and we want the pneumatics to work without someone having to manually pressing the solenoid or anything else, we need remote control. Two options for solenoid or compressor control are the serial pneumatic bumper, which can connect to multiple solenoids and compressors. This is more commonly used. And the pneumatic spike, or it's usually a normal spike, which is also used for electrical actuators, known as the Vex Pro spike. Most of you have heard of this type of spike, but it is less common. Other parts of a pneumatic system needed to work a pneumatic system are Teflon tape, flow control fittings, vibration dampers, as mentioned before, mounting brackets, and actuator magnetic retwisters. And finally, here's a sample pneumatic system. It may look complicated, but once you get started up, it's not that hard to build. Thank you for watching. This has been Parts of a Pneumatic System by Robotics CP.